We also might have just stumbled upon the mother of all water reserves, floating in space, and it's been hiding under our noses for at least around 12 billion years. As for its size, it's hard even to imagine. 140 trillion times larger than all the oceans on our home planet combined. This cosmic water world is orbiting around a large black hole known as a quasar, located 12 billion light-years away. Quasars feature supermassive black holes, spewing out colossal quantities of radiation. This one in particular is estimated to be 20 billion times heavier than our Sun, and carrying energy that could outshine 1,000 trillion of them. Here, in our cozy Milky Way, we're used to seeing water in ice form. This water reserve in particular seems to be in the shape of vapors. The important thing about this discovery is that there may be water everywhere in the universe. We just need to learn where to look. You might be surprised to learn that not all stars are hot to the touch. We used to think all stars were like our Sun, these blazing hot balls of fire, ready to melt anything in their path. Their cooler counterparts are called brown dwarfs. What makes them special is that they're too small to pull off the nuclear fusion that keeps stars like our Sun shining. They don't give off much light or heat, which makes them hard to see. These brown dwarfs are also split into different categories. There's this one group called Y-type stars, and they're the coldest, with a surface temperature lower than your average cup of tea. If you could reach out and touch one, you'd probably just feel a cozy warmth. Around 4 billion years ago, Uranus apparently switched places with Neptune. It's hard to imagine planets that big doing that, but this theory might solve the mystery of how our solar system came to be. We know that rocky planets formed after big collisions. Take our planet for instance. Around 4.6 billion years ago, things kept bumping into each other around the Sun until our watery Earth reached its final form. It also included one larger collision that blew up enough rock and gas for it to generate our moon. But when it comes to our larger solar system neighbors, Jupiter, Uranus, and Neptune, scientists still haven't got an answer. Standard models said it'd take forever for them to form, way longer than the solar system itself has been around. If this new theory is correct, it suggests that Uranus and Neptune came from this dense cloud of gas compacted around the Sun. Problem is, for the theory to make sense, they had to have swapped places at some point in history. Neptune is about 2.13 billion kilometers away, the farthest any planet can be in our solar system. Uranus is a bit closer, located at 3.5 billion kilometers. This new idea suggests that after they formed way closer to the Sun than they are today, their positions were altered. It could have either been because of many comets passing by over billions of years, slowly tugging the giant planets away. It's not a definitive answer to how gas giants were formed. It's more like a strong hunch, backed up by looking at a lot of numbers. Speaking of weird things found in our universe, what about this floating spoon that NASA's Curiosity rover took a picture of on Mars? As the machine was cruising around the red planet, it stumbled upon this oddly spoon-shaped rock during the summer of 2015. The rock has a handle and even throws shade on the ground. It's not a leftover utensil from some Martian picnic, but rather what NASA scientists call a ventifact. That means it's a rock that got sculpted by the wind. It's not the first time the Martian surface has delighted us with weird, windy sculptures. There was the face on Mars, a rat, and even jelly donuts. It's also possible that diamonds are raining down on over 1,900 exoplanets out there in space. Scientists found out that you don't need particularly hot temperatures for carbon to turn into diamonds, like it was previously believed. Up until recently, we only knew of Neptune and Uranus to potentially feature sparkling showers. Astronomers were onto this interesting phenomenon for about 4 decades, but these planets were hard to study. We've only had one space mission, Voyager 2, swing by for a peek. A lot of progress is being made, though, thanks to lab simulations. Neptune and Uranus are called the ice giants because their outer layers are filled with hydrogen, helium, water, and ammonia, what scientists call ice. And that gorgeous blue hue they have is due to the methane in their atmospheres. The beautiful diamondy phenomenon happens deep down, however. If we could visit, we would see that beneath the thick atmosphere, there are layers of very dense ice. And under all that pressure, chemical reactions are happening, possibly generating diamonds the size of a small town. We can't just dive into Neptune or Uranus with a diamond-seeking probe. Instead, the same conditions are being replicated in labs here on Earth, squeezing matter between diamond anvils and zapping it with lasers to mimic the extreme conditions. Under these circumstances, scientists managed to create artificial diamonds. Understanding how these rocks form down there could also explain why Neptune is hotter than it should be and why it's got such intense storms. These diamonds might also be the key to unlocking the mystery of Uranus and Neptune's weird magnetic fields. If we compare it to our planets, it doesn't behave the same way, so there may be weird things happening under the surface to affect the magnetism. NASA's plans include sending a new probe to Neptune or Uranus in the next decade. With the planets aligning just right in 2030, it's the perfect time to explore these potentially diamond-filled worlds up close. Planet Kepler 78b is another weird cosmic discovery. It's a hot, molten world that's doing laps around its star in record time, once every 8.5 hours, and pretty close, less than 1.6 million kilometers away. Hot environment aside, if we could set foot on its surface, we'd notice its sun being 80 times larger on its sky than the daily view we have here on Earth from our star. If we apply what we know so far about how planets form, this little guy shouldn't even be there. Specialists still don't have a clue how it came to be, or how it ended up where it is now. What we do know is that it will disappear soon. Sort of. Since it's so close to its start, this scorching, hot planet is going to collide with it in a couple of billion years. Sounds like a lot, but it's a cosmic jiffy. What's similar between our planet and Kepler 78b is the density. Sure, it's about 20% bigger than Earth and weighs almost double, but it's got that same solid interior. There's no possibility of it forming any closer to its star and simply moving away with time. It also couldn't have been born much further away and migrated in. Any movements inward would have been unstoppable, and it would have also collided with the star. This may not be a particularly groundbreaking discovery, but chances are you've never thought of it. There may be space dust in your hair right now. Every day, loads of outer space matter comes raining down on Earth. Sometimes we get flashy objects, like when a meteor turns into a meteorite by crashing down to the ground. But most of the time, it's quieter. This cosmic material drifts down through the atmosphere, landing softly as what we call space dust. It may not sound like much, but it does add up to around 14 tons every single day. This space dust contains tiny fragments of rock and metal, broken off from asteroids and comets during big collisions. These particles are very small. You can't see them without special tools, but every time you step outside, some of it might land in your hair. If you were floating in space, no one would be able to hear you whisper, talk, or even scream in horror at seeing a giant asteroid coming towards you. It's not only that you'd be far away from Earth, but sound needs space to travel through. Sounds are just vibrations of molecules and atoms in some medium, like water or air. Your body will pick up sound waves through the ear canal and to the eardrum. Vibrations we receive then transform into electrical signals so our brain can understand and recognize them. Frequencies of sounds humans can hear are between 20 to 20,000 hertz. Sound travels 4 times faster in water because molecules are closer together than in air. Naturally, it travels faster through steel than both water and air. The loudest natural sound on our planet is one made by an erupting volcano. Not 100% certain, but scientists believe the eruption of Krakatoa in 1883 was probably the loudest sound humankind ever had a chance to hear. It exploded with enormous force, destroyed its island, and released 20 million tons of sulfur into the atmosphere. People even heard it 3,000 miles away. It would be like someone producing a sound in New York, and people hearing it all the way in Ireland. Sound can take many forms, but humans are most familiar with it in the form of pressure waves that move through the air. Sound goes more slowly through heavy gases and colder air. It travels faster through lighter gases, for example, helium. There's no water or air in space, so the sound that doesn't have anything to travel through. Our atmosphere consists of 10 trillion atoms, which is like dense soup creating a way for sound to travel. And there are only 10 atoms per cubic meter up in space. That means space is empty and silent. But it wasn't always like that. The universe is 10 to 20 billion years old. It appeared as a result of the Big Bang. It wasn't an explosion that started from just one single point, but rather space appearing everywhere in the universe at the same time. Back then, the whole universe was like a hot ball of plasma. It was much thicker than today, so the sound could pass through it. As the universe was forming, it produced shock waves, and they, in their turn, produced a cosmic rumble, way deeper than things our ears can normally detect. These are the actual and the first sounds the universe ever produced, at the stage when it was still forming. Scientists decoded them and pitched them up to a version we can actually hear. As time went by, the universe was stretching. Today, it's a lot wider, emptier, and quieter. It's good for us, though. If sound traveled through space with ease, we would constantly hear loud explosions, crackles, moans, and other sounds space bodies make out there. The sun isn't silent either. Here's the sound of its vibrations created by its loops, waves, eruptions, and other activity. The sun creates trillions and trillions of watts of sound energy, something like pulsation, low heartbeat. It helps researchers discover what's going on inside of the sun and understand its layers. If it wasn't muted for us on Earth by the lack of air in space, it would be like hearing a jackhammer all the time. If you and your friend were taking a walk on the surface of the moon, you wouldn't be able to hear each other talk. No air, no sound. But that doesn't mean the moon itself doesn't produce any sound. When the first spacecraft landed on the moon, it caused crashes which later led to moonquakes. Scientists took a chance to measure vibrations going through the moon to figure its internal structure. They realized they caused vibrations that lasted longer than they expected. Any similar vibrations on Earth. It was like those moonquakes were producing the sound of a ringing bell. When we have earthquakes, moisture in the ground acts like a sponge. It absorbs the energy of the waves spreading around until it ends their effects, which is why water eventually stops the earthquake. The moon is dry, more like a solid rock. Moonquakes are less intense, but there's no water to stop them, so vibrations just go back and forth through the moon. The solid rock stops them at some point, which is when the ringing stops too. Let's see what happens with the sound on different planets. Neptune, Uranus, and Saturn are mostly made of helium and hydrogen. These gases are way lighter than the atmosphere on our planet, so your voice there would generally come out in a higher pitch. But each planet has its layers that make differences in sound. Neptune has its murky depths, Uranus its methane clouds, but they're both freezing, made of gas, and have ice particles in their atmosphere. Saturn, also a gas giant, boasts wild, raging storms. Saturn's biggest moon Titan is the only one known for having a real atmosphere. It's thicker than the one we have on Earth. It's very cold there, and it rains liquid methane. In 2005, researchers sent the Huygens spacecraft that managed to record incredible audio you might find familiar. the sound of the winds, but billions of miles away from us, on Titan itself. If you were there, you might even hear the sound that reminds of a waterfall, while, in reality, it's flowing, liquid methane. Moving to Jupiter. It doesn't have a solid surface either. It's made of gas that becomes denser the deeper you go. At some point, it even turns into a liquid. The sound is different in each of those layers. Jupiter is actually pretty noisy and has bizarre sounds. It creates intense radio storms with powerful lightning bolts. While there, you'd hear their echoes of echoes, just going back and forth. Mars. Its atmosphere is way thinner than Earth's, which means there are not many molecules for sound to travel. Winds can get pretty fast, like our hurricanes, but on Mars, they would feel like a gentle breeze. You wouldn't necessarily hear the storm, though. You'd maybe hear the dust as it gets picked up and banged against your spacesuit. In the thin atmosphere, your voice would be much quieter, and it wouldn't travel far. Someone could be standing next to you and screaming, and you'd probably hear nothing. Low-density air usually makes our voices sound higher-pitched, but the cold temperatures, like on Mars, slow down the sound so it would balance out again. Your voice there would sound a bit distant and blurry, and imagine listening to an instrument like a guitar or piano there, like some muffled melody from a dream. Sound on Venus is kinda the opposite of Mars. Venus has a dense atmosphere, much denser than ours, something between water and air. There, you'd hear sounds like when you're underwater. The environment is a bit different with 900 AF, 482 DAC, and 100 tons of atmospheric pressure. But let's say you have a magical spacesuit that protects you from getting crushed or scorched. While on Venus, you'd hear thunder. 40 years ago, a spacecraft successfully landed on its surface and managed to go almost an hour before it shut down. It picked these amazing sounds of strong winds. If you started talking on Venus, your voice would first hit the lower pitch because of the dense atmosphere, but it would then sound higher because hot air increases the speed of sound. It would all be kinda distorted and muffled together with the sounds of thunder around you. Mercury is a rocky body with no atmosphere, so standing on its surface and talking would be like trying to talk while floating in space. Useless. Those are almost vacuum conditions, which would make you think Mercury has no sounds at all. Still, you can hear them, though not in the air. The rocks. Put your ear against the ground. Maybe a Mercury quake is coming. The universe is a place connected by light. Light can go anywhere from any spot in space, but not the sound. So, not only do we have a planet that supports life, but offers a wide palette of sounds. Even without us, it wouldn't be a quiet spot. A light breeze gently caressing treetops, earthquakes, volcanoes, deserts. The ocean with its waves on the surface and scary sounds deep below. Up there, it's a quiet mystery, but down here is true magic. Mercury. About 3.8 billion years ago, a huge asteroid is about to collide with the planet. Boom! Fragments are flying in different directions, along with the blast wave. When the dust settles, we see a crater almost the size of Lake Ontario. The most interesting thing here is the shape of the crater. It looks like a spider. A round body in the center, and a bunch of legs that spread out from the crater in different directions. But the strangest thing is that the spider's legs don't quite line up with the center. Scientists can only guess how such a landscape was formed. Some think that the picture of the spider appeared there much earlier, and the meteorite falling almost into its center was just a coincidence. But we still don't have a clear explanation of how such scars could have appeared on the surface of Mercury. Another mystery about Mercury is how it was born. One theory claims that the planet used to be Venus's moon, but over time, it succumbed to the sun's gravity. The star literally ripped Mercury away, and the little planet began orbiting it. What might prove this theory is the rotation periods of Mercury and Venus. Mercury is gradually losing its rotational speed. One day on this planet now equals 58 Earth days and continues to increase. At the same time, after losing its heavy load, Venus has started rotating a little faster. Another theory says that Mercury collided with Venus shortly after the appearance of the solar system. At that time, Proto-Mercury was slightly larger than the planet we're familiar with these days. But then, Mercury lost part of its crust after colliding with Venus, and a little later, Venus collected this debris. But scientists still can't come up with a definite answer as to how Mercury was formed. Uranus, a gas giant, 18 Earth-Sun distances from our home. This planet seems calm compared to other giants, like Jupiter with its Earth-sized storms. And still, Uranus has something unusual to boast about. This dark spot, for example, was detected by the Hubble telescope in 2006. At that time, it was almost twice the size of Alaska. A few years later, bright spots appeared there. It turned out that they were methane clouds that moved across the surface of the planet at a speed of 300 miles per hour. But we don't know what exactly causes such storms on Uranus. Maybe we can solve this secret by looking at another mystery of Uranus. This planet rotates while lying on its side. If you look at the axis of our planet, you'll see that it is vertical and only slightly tilted. It's the same for most of the planets in our solar system, but not Uranus. Its axis is almost horizontal and pointed toward the sun. One of the poles of Uranus is fully illuminated at almost all times. The polar day on the planet lasts for 42 Earth years. When the tilt of Uranus's axis changes, the polar day starts on the other side of the planet. The other pole plunges into darkness for 42 years. This change of seasons can cause severe storms on the planet's surface, but why exactly Uranus lies on its side is unknown. Perhaps billions of years ago, the gas giant collided with several asteroids that were about to become a young planet. Such a protoplanet, similar in size and weight to Earth, could have tilted Uranus after crashing into it, but it's still just a hypothesis. Now, let's go to Jupiter's moon, Europa. The big mystery here is whether there is life on this moon. Scientists don't deny such a possibility. All you see on the moon's surface is ice. The stripes you may spot are actually long, wide cracks. For a long time, scientists thought this moon was nothing more than a block of ice. But now, they think there might be liquid water inside. The core of Europa is heated by the tidal forces of Jupiter. This warm core melts the ice around it. So, there really could be a huge ocean under the ice crust. Since water is the basis of life, different microorganisms could exist there. But we would only find out if we sent a probe there. We would have to drill through 24 miles of solid ice and start searching in an ocean twice the size of all water reservoirs on Earth. Look at Saturn's moon Titan. It's the second largest moon in the solar system. It's 50% bigger than Earth's natural satellite. It's the only place in our solar system other than Earth where liquid water has been proven to exist. But the most interesting thing about Titan is its atmosphere. It's 250 miles thick. This distance is almost 40 times greater than the average cruising altitude of commercial planes on Earth, and it's 95% nitrogen. For comparison, Earth's atmosphere is 79% nitrogen, which means they're quite similar. The mystery is that no one knows how this atmosphere appeared there. One theory suggests that many years ago, meteorites hit Titan's surface almost non-stop. Massive rocks collided with the crust, raising the pressure and temperatures on the moon. Under such conditions, the ammonia in the air decomposed into nitrogen and hydrogen. The heavy nitrogen fell on Titan's surface while the light hydrogen rose and flowed out into space. But some scientists dispute this theory. Another mystery of the solar system is the hypothetical star Nemesis and whether it really exists. If you look at all the stars of our galaxy, most of them are paired, which means that two stars orbit around each other. Statistically, the sun must also have a companion. So some scientists have made an assumption that the largest mass extinctions on Earth were related to some mysterious object in space. They hypothesized that there was a red dwarf somewhere within 1.5 light years away from the center of the solar system, and every approach of this dwarf star to the asteroid cloud disturbed these space travelers. Every time it happened, several asteroids began their journey toward Earth and caused a mass extinction. But this star hasn't yet been discovered, and many scientists question this hypothesis. Now, let's look at the very edge of the solar system. A photon of light has to travel 1 year to get here. Scientists believe the Oort cloud exists in that area. It's a hypothetical region where tons of asteroids and blocks of ice gather into clouds. It's the furthest place where the sun's gravity still works. Presumably, this spherical cloud wraps around the solar system. This is the region where long-period comets are thought to originate. They fly all the way through the solar system and then return to the Oort cloud. This journey can take thousands of years. Even more exciting, there could be a gas giant called Tyche in that region. Some scientists say it might be 4 times the size of Jupiter. So far, no research has confirmed its existence. Although the Oort cloud is still considered hypothetical, some scientists believe that comets from that area are responsible for the major mass extinctions on Earth. Now, let's go beyond the borders of the solar system. There, 1,500 light-years away from Earth, there's the closest to our home planet black hole. Black holes are the most mysterious objects in the universe. They're so heavy that they attract not only matter, but also light. Even more, they slow down time. Once something gets trapped in a black hole's gravity, it never escapes. Light and matter gradually settle near the event horizon and soon disappear into infinite darkness. Time flows differently here. 1 minute near a black hole can be equal to weeks on Earth. The biggest mystery is what exactly is inside a black hole. Some speculate that there's nothing but crushing pressure that destroys anything that gets there. Others say it might be a portal to another dimension, or a wormhole to another place in the universe. If it was true, white holes would exist as well as exits from black hole portals and wormholes. But no white hole has been found so far. Now, how about going to the hypothetical border of the entire universe? It's called the Eridanus supervoid. If you look at the map of the universe, you'll see an empty cold spot about 1 billion light-years wide. The entire Milky Way galaxy is only 100,000 light-years across. The main mystery is how the spot appeared. One theory says this void is the scar left by the collision of 2 parallel universes. Imagine that universes are giant bubbles, and one day, 2 of these bubbles collided. That's when the parallel universe ripped several galaxies out of our bubble. So far, this is the only explanation for how such a huge cold void could appear in our universe. Did you know that our sun is actually green? Okay, I'm kidding. In reality, it's all colors you can imagine at the same time. Wait, what? I know it sounds like a joke, but I'm being serious. Can't you tell? In fact, our sun contains absolutely all the waves of the light spectrum. It's simultaneously red, blue, green, yellow, you name it. Where do you think rainbows come from? When sunlight gets reflected off water droplets in the air, it splits into a bunch of colored waves that we can see individually. And when they're all together, we see a white ray of light. Our eyes are unable to perceive the concept of all colors at the same time, so their combination seems white to us. Wait, you might say, why white? Isn't the sun yellow? Yep, it's yellow too. But please don't stare at the sun just to make sure. It appears white when we see it from the International Space Station. This is the sun's real color as our eyes perceive it. The sun gets a yellowish hue when its rays get scattered in Earth's atmosphere. Our atmosphere doesn't let the blue rays of the spectrum pass well, but the red ones? Sure, why not? By the way, that's why the sky seems blue to us. The atmosphere scatters the blue color all over the place. During sunrise and sunset, short blue waves get reflected, but the long red ones reach us perfectly. That's why we see sunsets as pink, orange, or red. But what would happen if the sun had a different color? To answer this question, let's quickly repeat what we've learned. 1. The sun has the whole color spectrum in it. 2. Our atmosphere is like blue rays, nope, red rays, anytime. So you've probably already guessed what would happen if the sun was, let's say, red. The whole world would look like it does during sunsets. Not bad, huh? We wouldn't even have to wait for the evening to admire the scarlet sky, orange water, and a bright red moon. Yeah, it would be darker than what we're used to, but still not bad. By the way, one day, the sun will actually turn red. When its life comes to an end, it will expand and gradually turn into a red giant before finally burning out. But it's not going to be much fun for us, so let's hope we won't be around to see that moment. I know I won't. I have a party to go to. Okay, now, what if the sun was green? Well, the truth is, the sun is green. Here's your dialogue. Wait, are you kidding me? Didn't you just say that it's white? Good job on that, by the way. Not exactly, bud. The sun just looks white. But technically, it has a temperature of about 10,000 degrees of Fahrenheit. And the peak wavelength of the sun's spectrum corresponds to the green-blue hue. But to make sure that the sun is green, we need to drown out the rest of the visible spectrum. Then our atmosphere will let through a pure green color. And what will happen then? Well, everything will be green, and everything will also become a bit darker. Face it, it's not easy being green. Okay, moving on. Now let's paint the sun blue. Blue stars actually do exist. They are called blue giants. Fortunately, our sun is not one of them. Why fortunately? Well, because if it was a blue giant, it would be a young, beautiful, unimaginably large, and very, very hot star. See, our red is hot. Blue is cold logic doesn't apply to stars. The hottest stars are white and blue, and the coldest are yellow and red. Yeah, our sun is actually very cold compared to other stars. Now, take the average temperature in your city, but multiply it by, like, hundreds of thousands. Yeah, we're struggling with global warming here, but global burning? No thanks, blue giants. Anyway, let's imagine that the sun turned blue. How would we see the world? Surprisingly, nothing would change. Remember how I said that the atmosphere scatters blue light? That's why, in this case, everything would remain almost the same. Maybe the sky would get bluer, but we wouldn't see much difference. And finally, the darkest, pun intended, option. What if our sun turned black? Stock up on lamps and candles because there is no more light. People use electricity all over the world 24/7. We also can't see the moon anymore. After all, we can observe it these days only because the sun's rays get reflected off it. Now, the only thing we still have to illuminate our nights are stars. But they don't help us much. Good thing this scenario is totally unrealistic, and there are no black stars. Yeah, there are no black stars. And still, our sun will eventually become completely black one day. And I don't mean a black hole. I'm talking about black dwarfs here. You've probably heard of white dwarfs, maybe even seven dwarfs. When a star like our sun is about to finish its life, it expands and turns into a red giant. And then, gradually losing its upper layers, it turns into white dwarfs. Since they no longer produce fuel, they slowly cool down. All that remains is a small core, living out its life and burning bright. And when the star cools down completely, right, it turns into a black dwarf. But you've probably never heard of them. Why? Because surprise, surprise, they don't exist. And no, I was not lying. The thing is, a star needs about 1 quadrillion years to turn into a black dwarf. And our universe is still a baby. It's only about 14 billion years old. So, no star has reached this stage yet. Even the most ancient of them still emit a little light. That's why black stars are just a theory, and it's unlikely that we'll ever see such a star at all. But remember the famous saying, the stars that we see at night are already ghosts because their light has reached us only now? That's a myth. They're all still alive. Why am I telling you all of this? Let's imagine that our sun turned into a black dwarf. The entire solar system would immediately get plunged into absolute darkness. It would also be terribly cold. The moon would leave its orbit and crash into Earth. Wait, no. Let's overlook this moment and assume that we're still alive. Fortunately, we wouldn't freeze instantly as you might think. Earth's core has its own temperature, more than 9,000 degrees of Fahrenheit. Temperatures on the surface of the planet would still immediately drop to 32 degrees. The core would gradually cool down. Every 2 months, its temperature would drop by 2 times. In just 2 months, Earth's surface temperature would be 190 degrees of Fahrenheit, and in a year, it'd reach 450 degrees of Fahrenheit. Most plants would disappear pretty quickly, not because of the cold, but because of the lack of photosynthesis. Others would live a little longer thanks to the oxygen still remaining in the atmosphere. And, oddly enough, trees would survive for a very long time. They have a slow metabolism and get sugar from the ground. The upper layer of the oceans would freeze pretty quickly. Fortunately, this thick crust of ice would insulate deep waters, so the entire ocean wouldn't freeze for some time. Marine creatures would be doing pretty well. They existed long before us, and are already used to crazy temperature changes, the lack of oxygen and food, huge pressures, and other joys of deep-sea life. And what about us humans? First of all, we'd start getting sick. Without vitamin D, people would face a huge number of different health problems. Also, our bodies need sunlight to produce melatonin. This melatonin helps us understand when we should go to bed and wake up. If people didn't have this hormone, their bodies would get very confused and wouldn't understand whether they needed to sleep or not. That would mean insomnia for many people. But we would still be able to survive. We'd have two options: to build giant submarines and go down to the depths of the ocean, closer to Earth's core, or stay on the surface, living our lives in some location where we'd have sources of geothermal energy. In Iceland, for example. We could also settle near volcanoes. Their heat would be enough to warm us for a long time. Our vision would adapt to the dark, but at some point it'd reach its maximum. So we'd need to get used to living in complete darkness. But who knows? Maybe we would adapt to this life too. Which option would you prefer? Living at the bottom of the ocean in a submarine, or on the surface near volcanoes? Our solar system might have some more planets up its sleeve. We know about 8 official planets, but they're not the only ones that survived the chaotic formation of our solar system 4.5 billion years ago. Astronomers say there are 3 categories of planets in our solar system. We're in the first one, the 4 rocky inner planets: Mercury, Venus, Earth, Mars, that peacefully orbit the Sun. They're located within the main asteroid belt that separates Mars from Jupiter, which is in category number 2. That one's a group of planets in the outer solar system, the gas giants: Jupiter, Saturn, Uranus, Neptune. These planets have huge amounts of ice and gas around what scientists believe to be their rocky cores. The third group lies beyond the area where our local planets are, somewhere further than Neptune. It's the realm where you'll find dwarf planets such as Pluto, Eris, and Sedna, and many smaller space bodies like comets. But new findings say there could be something else lurking in the dark, besides dwarf planets and tiny space bodies, maybe even a new planet. Models scientists made say that our outer solar system used to have 1 or more rocky planets, the size of Mars or Earth. Over time, these rocky wanderers interacted with the wide gravity fields of our gas giants. This kicked them into a far-out orbit, away from the neighborhood. The question is if one of those Mars-sized planets survived and could really be somewhere out there. Scientists have made simulations to see what potentially happened. These showed that in half of such cases, where planets interact with the gravity of gas giants, they get ejected into interstellar space. In the remaining half, there's this one rogue planet, left in an orbit similar to ones the Kuiper Belt objects are following. There's only one thing left to do now: find it. Astronomers found the loneliest planet in the universe. They were trying to find distant brown dwarf stars, or failed stars, ones that never become massive enough to start shining. Stars are born with big masses, which means they also have strong self-gravity. The star squeezes in on itself. That causes high internal temperatures and enables the star to shine. But instead, they found a lonely wanderer, CFB DSIR 49. The planet is between 50 and 120 million years old and has a surface temperature of 750 degrees. Compared to stars, that's cold. At first, scientists thought it could be a brown dwarf star, but in that case, it would be way older. This starless planet floats around through space, passing only 130 light years away from our planet. Our galaxy, the Milky Way, is 100,000 light years wide, so that's relatively close. The Lonely Traveler is actually a gas giant, 4 to 7 times bigger than Jupiter. Maybe it was kicked out from its own solar system because of gravitational forces, or getting into another planet's orbit, or it was formed away from its parent star. Far beyond Pluto, on the edge of our solar system, There's a space body about as big as Pluto, but a little bit colder and way denser. It's probably a big rocky body covered in a thin icy mantle. It's the dwarf planet Eris. Both Pluto and Eris occupy the Kuiper Belt, which is the distant ring of frigid space bodies that lies beyond Neptune. A day there lasts 25.9 hours, pretty similar to Earth. But Eris circles our sun in the distance 3 times farther than Pluto, which means its year is pretty long, 557 Earth years. Eris has a bright, icy surface. It's one of the most reflective bodies in our solar system. It bounces back more than 95% of the light that strikes it. Somewhere out there, even farther, there's a super Saturn, J-Watino-7b, much larger than Jupiter or Saturn. It's an exoplanet, which means a planet that orbits a star other than our sun. Super Saturn is 434 light-years away from Earth, constellation of Centaurus. It's the only exoplanet we know about with rings similar to Saturn. It actually has a huge ring system, 200 times bigger than Saturn's rings. There are more than 30 rings, each of them tens of millions of miles in diameter. There are gaps in the rings, which means there could be some interesting satellites, exomoons, around. If this super Saturn could swap places with our regular Saturn, its rings would absolutely dominate our sky. You could look up and easily see them. The view would be amazing because they would appear much bigger than a full moon. Scientists have found thousands of planets outside of our solar system. Some are dense as iron, while others are airy and light. And then there's the water world, GJ-1214b, a steamy world bigger than Earth and smaller than Uranus, 40 light-years away from us. Constellation of Ophiuchus. It's a watery planet surrounded by a thick atmosphere, 2.7 times Earth's diameter, and almost 7 times heavier than our home planet. It was most likely formed somewhere farther from its star, where there was plenty of water ice, but later migrated to where it is today. Its surface temperature is 440 degrees, which is too hot to host life like on Earth. It also has much less rock and much more water than our planet. Imagine a planet with no land, but only endless oceans covering all of its surface. High pressures and temperatures would form things like superfluid water or hot ice, some pretty exotic materials that we can't see on our planet. Gliese 436b. It's a Neptune-sized exoplanet, 30 light-years away from our planet, constellation of Leo. It makes one full orbit around its star in a little more than 2 days. This planet defies the laws of physics. It orbits its star, Gliese 436, which is smaller, cooler, and less luminous than our sun, at a distance 15 times closer than Mercury is to the sun. When we typically think of ice, we picture a frozen cube, even though the temperature there is 980 degrees. This temperature is way above the melting point, but the ice remains solid and burning hot. This happens because of very strong gravity. It compresses the water vapor in the atmosphere into solid ice. The pressure here doesn't allow the ice to melt, no matter how hot the surface is. Now imagine being on a mysterious planet and it suddenly starts raining sapphires and rubies. One distant exoplanet, HAT P7b, a gas giant 1,000 light-years away from Earth in the constellation of Cygnus and 16 times bigger, has specific weather with pretty violent storms. Rubies and sapphires are scattered across the planet when it's raining. On the planet's night side, there's a high amount of corundum in the atmosphere. And corundum is what mineral gems such as sapphires and rubies are made of. Clouds of corundum give such an amazing view. The planet is plagued by severe winds that often turn into powerful storms that push huge masses of those clouds across the planet. Although the planet is uninhabitable, it would certainly be cool to come there and pick up some gems. Still, the weather is pretty wild. Plus, the temperatures are over 4,600 degrees. By comparison, Venus is the hottest planet in our solar system, and its temperature is only 900. Looking over the expanse of space, you can see a beautiful little blue dot in the endless darkness. It's an exoplanet, HD 189733b, that lies 63 light-years from us in the constellation of Vulpecula. But it's way hotter and larger than our planet, around the size of Jupiter, and completes the orbit around its host star in only 2.2 Earth days. That orbit is so close that the planet is most likely tidally locked. That means it's always showing only one face to its star, like our moon always shows one side to Earth. The weather here is crazy, which is 7 times the speed of sound. The fastest wind on Earth only hit the mark of 230, and it gets better. The rain here is not made of water, but of molten glass. Clouds are made of silicate atoms and particles. They are the key element that gives the planet its cobalt blue color, not the reflection of oceans, which is the case with Earth. Earth used to be purple. Today, even when you look at our planet from space, you see a lot of green. The green we see in nature is there because of photosynthesis, the process where plants transform energy coming from the sun into energy they need to live and to produce oxygen. The main part of the process that gives plants the green color is the chlorophyll pigment. A long time ago, instead of chlorophyll, there was a molecule called retinol. Its pigments absorb yellow and green light and turn it into red and blue, so the Earth was more purple. And then there's a pink planet, GJ 504b, far away from us. Virgo constellation, 4 times more massive than Jupiter. It's a newly formed exoplanet, around 160 million years old. For comparison, the Earth is 4.5 billion years old. If we could go there, we would see an incredible world that glows from the heat of its formation. Everything around you would be colored magenta. Our universe is full of both amazing and terrifying things. You already know about quasars, black holes, dark matter, and so on. But how about the horrors of space that you haven't even heard of? Would you like to visit the most bizarre worlds in the universe? And it's not me who made this list, but NASA themselves. Welcome to the Galaxy of Horrors, NASA's awesome Halloween collection. Please join me on a journey to some planets and tell me which one you will consider the most horrible. Buckle up. Our first destination is a gas giant called TRES 2b. It's located 750 light-years away from us. If we used a regular spaceship, it would take us about 10 million years to get there. Orbits a yellow dwarf, a star similar to our Sun. It also weighs about 1.5 times more than Jupiter. So, what's so special about it? Well, if you're afraid of the dark, you definitely don't want to visit this place. It's the planet of eternal night, the darkest one of all the planets known to us. But it's not that far from its star, so why is that? The thing is, the surface of TRES 2b reflects light even worse than coal does. Because of this, it seems that there's no light at all. If you were flying across the surface of this planet, it would be like walking with a blindfold on your eyes. Oh, wait. Actually, there is some light. An eerie, deep red glow surrounds the surface of the planet. This glow is created by the burning atmosphere, which makes TRES 2b a scorching planet. The air there is even hotter than lava. Oh, but if you think that was bad, let me show you the next place of our horror journey. NASA wasn't beating about the bush while nicknaming this one. Now, we're not just talking about one planet, but 3 at once. They're also located quite far away, 2,300 light-years from the Sun. We would have reached them by ship in about 35 million years. All the planets are in the constellation Virgo, and each is extremely light, much lighter than the Earth. These 3 exoplanets are called Poltergeist, Draugr, and Phobator. Cool names, huh? It's because each of these planets is about to become a ghost soon. The thing is, they don't revolve around a star, but around a pulsar. Pulsars are rotating neutron stars with an extremely powerful magnetic field. In simple words, these are the stars that exploded one day. After the explosion, they usually emit such a powerful pulse that it causes the star to rotate at an unimaginable speed, several thousand rotations per second. At the same time, they constantly emit electromagnetic pulses that affect everything around them. So, you've probably already guessed what is happening with our zombie planets. They're slowly, gradually being destroyed under the gigantic influence of radiation. One day, they'll disappear without a trace, ghost-like planets orbiting an undead star. Yeah, Zombie World is a fitting name. It's also not surprising that scientists nicknamed this pulsar Lich, despite the long official name. Well, at least these guys stick together on their final dance. This planet has a long name, so bear with me. HD 18733b. This gas giant is 65 light-years away from us. It would have taken around 1 million years to get there on a spaceship. HD, this planet is slightly more massive than Jupiter and orbits its star, an orange dwarf, all alone. At first glance, it may seem friendly. Pleasant blue color and curls on the surface. Kinda resembles a summer sky or foam on sea waves, right? Oh, looks are very deceptive, my friend. This planet has a pleasant cobalt blue color due to the hazy blowtorched atmosphere. This atmosphere contains silicates that condense when heated. In other words, the clouds on this planet have rain, made of glass. Yes, it rains hot glass shards here. Oh, and if that's not enough, there's a raging wind on the surface, which is moving at a speed of 5,400 miles per hour. Just to compare, the fastest wind on Earth had a speed of 254 miles per hour, about 20 times weaker. And because of this, hundreds of thousands of glass shards rush horizontally across the planet's surface at breakneck speed. I really don't envy anyone who would try to land here. By the way, this isn't the only example of strange rains in our universe. For example, it rains molten iron on the planet Dimidium. Or let's take so-called carbon planets. Their existence hasn't yet been proven, but if they do exist, there would be tons of black, poisonous clouds, and it would rain pure gasoline and hot liquid asphalt. Oh, and also, raindrops would explode upon touching the surface. Nothing special. The next planet, though, is actually really strange. It didn't just revolve around its star, it lived inside the star. This cosmic miracle is called KOI 55b, or Kepler 70b. This planet is very far away from us, 4,000 light-years. It would take about 70 million years on a spaceship. It's twice as light as Earth and fully rotates around its star in just a couple of hours. A long time ago, it was an ordinary Earth-like planet about the size of Jupiter. It was peacefully and calmly orbiting its red dwarf star, KOI 55. But everything changed about 700 million years ago. Perhaps you've heard that in a couple of billion years, our sun will begin to expand into a huge star, absorbing everything in its path. This is the fate of red dwarfs. Sooner or later, they increase, turning into incredibly hot blue giants. The same thing happened with KOI 55. This star began to increase in size and heat up in temperature, gradually turning into a blue-white giant. It was ready to devour its nearest planets. But KOI 55b didn't care about it. When the star reached it, this planet just settled inside. And moreover, after some time, it left its star, simply returning to the new orbit. How is that even possible? Life inside its star turned KOI 55b into a red-hot roundstone. It's one of the hottest planets we've discovered so far. The temperature on it reaches 12,000 degrees of Fahrenheit. It's hotter than the sun, which is, let me remind you, an actual star. And for some reason, it's still alive and lives as if nothing happened. Unfortunately, sooner or later, the planet will disappear anyway. It's slowly evaporating itself due to the incandescent atmosphere. But still, it somehow managed to survive the journey through the star, which isn't typical for the regular planets, to put it mildly. I envy this willpower. However, not all planets are so lucky. Some are gradually being destroyed by their stars, and there is even an entire system among them. This last planet is a sad loner. It's located 870 light-years away from us. The journey by ship to it would take about 25 million years. This planet is about 1.5 times more massive than Jupiter. This is a very sad, dark planet. A doomed gas giant, which is very similar to hot Jupiter, orbits its star all alone. At the same time, it's located so close to its star that its orbital period takes just 1 day. Of course, because of this proximity, the star gradually absorbs WASP-12b. The scorching heat of the star is slowly destroying and devouring the planet's atmosphere. The planet has only around 10 million years left. But what's more interesting, because of this stretching, WASP-12b acquired the shape of an egg. It doesn't even resemble an actual planet anymore. It's also very hot. The surface temperature of the gas giant reaches 4,000 degrees of Fahrenheit. Also, a spectrograph of cosmic origin, or QIS for short, found that the planet exchanges matter with its star. They're located so close that they give each other part of their chemical elements. This is a common phenomenon in closely spaced binary star systems. But this is the first time scientists have seen this in a star-planet relationship. What a unique system. To be honest, if I was guaranteed complete security, I'd be excited to visit at least some of them. What about you? Please let me know in the comments. It's dark outside, almost 2 a.m. You go outside and look at the sky, and here it is, bright full moon. You might think you know a lot about Earth's natural satellite, but let me ask you this: how did it form? The answer is nobody knows. But, of course, there are theories. The most popular one, called the giant impact theory, claims that the moon formed during a collision between Earth and another planet. This planet must have been smaller than ours, the size of Mars, and the collision itself probably happened around 4.5 billion years ago. Another theory, called the capture theory, claims that the moon used to be an asteroid or some other wandering body. It formed somewhere else in the solar system. When it was passing by Earth, it got caught by our planet's gravity. But here is one catch. Our planet and the moon have remarkable isotopic and chemical similarities. So, they must have a linked history, which means the moon couldn't have been created elsewhere. Other experts think that at some point in the past, Earth was spinning so fast that some of its material broke away. It soon started to orbit our planet. That's how the moon appeared in the sky. But again, there's one problem. In this case, the proportion and type of minerals on the moon would have to be the same as on Earth. But there are slight differences. The moon is richer in materials that form very fast at high temperatures. There's one more theory, and it's probably the least exciting. It claims that Earth's natural satellite could simply appear along with Earth during our planet's formation. Duh. But these days, a more urgent question keeps astronomers busy. Is the moon really Earth's satellite, or are these two twin planets? The moon is big compared to our planet, about 1/4 of Earth's size. That's why some experts refer to our planetary system as a double planet. But how correct is that? If we want to figure it out, we need to give the definition to the word planet. According to the International Astronomical Union, a planet is a space body that orbits the sun, is massive enough to have a nearly round shape thanks to its gravity, and has cleared the region around its orbit. Now, what about a satellite? It's an object in space that orbits around a larger celestial body. If we take the system, Earth the Moon, its center of gravity, called a barycenter, is inside Earth. That's why at the moment, we can't say that we live in a twin planet system. According to this definition, the moon is the satellite of our planet. Now, let's get back to the past, like 3 or 4 billion years ago. Even though the moon wasn't a planet, it most likely had a full-fledged atmosphere. It formed at times when powerful volcanic eruptions were rocking our satellite. Gases spread all over the moon's surface, and it happened so fast that they didn't have enough time to escape into space. At that time, the lunar surface was covered with basins filled with volcanic basalt. Just imagine ginormous plumes of magma hurtling high into the air, falling to the ground, and creating lava flows. That's how the basalt basins appeared on the surface of the moon. At one point, scientists got their hands on samples brought from the moon. They found out that lava flows there contained not only carbon monoxide and sulfur, but also the building blocks of water. Thanks to these samples, researchers managed to calculate the amount of gas that rose and formed the atmosphere. It became the thickest around 3.5 billion years ago and existed for about 70 million years. After that, poof, the atmosphere was lost in space. But the coolest thing? When the moon did have an atmosphere, the satellite was 3 to 10 times closer to our planet. One computer simulation even suggests the moon was probably up to 19 times closer than it is now. The distance between it and our planet could be 18,600 miles, while these days, our satellite is around 240,000 miles away. That's why the moon looked much bigger in the sky. Unfortunately, at that time, not even dinos were around to admire the view. These days, the atmosphere of the moon is almost non-existent, and that's why the satellite can't protect itself from meteorites. The surface of the moon is dotted with craters. For comparison, there are about 190 identified impact craters on our planet. Many of them are hidden by vegetation or covered with water. But if we speak about the moon, the number is so much greater, several million, and around 5,000 of them are more than 12 miles across. And since the moon is less seismically active than Earth, these craters and other ancient formations stay in perfect condition for centuries. When you look at the moon, it's the brightest object in the night sky. But in reality, its surface is dark because the reflectance of our natural satellite is just a bit higher than that of asphalt. You might know that the moon's gravitational pull causes tides on our planet, making the oceans bulge out on both the side closest to the moon and the one farthest from the satellite. But that's not all. The moon also slows down Earth's rotation. This phenomenon is known as tidal braking. It increases the length of a day on Earth by a bit more than 2 milliseconds per 100 years. The moon is also moving away from Earth at the same rate at which your fingernails grow. That's about 1.5 inches per year. If one day the moon floats away into space, our planet will have to live through tough times. Without the stabilizing pull of the moon's gravity, Earth's tilt would start changing wildly. From no tilt at all, meaning no seasons, to a large tilt, resulting in extreme weather. Even though the moon's surface is mostly dormant, Earth's natural satellite still experiences moonquakes. One theory suggests that they may be happening because the moon is shrinking as its insides are cooling. Scientists say the moon has become around 150 feet skinnier than it used to be several hundred million years ago. To help you understand it, picture a grape turning into a raisin. It wrinkles while shrinking. The same is happening to the moon. It's shrinking and it's wrinkling. But unlike a grape, the moon doesn't have flexible skin. Its surface is hard and brittle. So, as the moon gets smaller, the crust cracks and breaks, and its sections get pushed over neighboring parts. Want to know another cool thing about the moon? A recent study claims that it has a tail, and every month, it wraps around our planet like a scarf. This slender tail is made up of millions of atoms of sodium, and our planet regularly travels directly through it. Meteor strikes plus these sodium atoms out of the moon's surface and further into space. For several days every month, the moon remains between the sun and our planet. That's when Earth's gravity picks that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But during those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the full moon's diameter. And the spiciest fact for you, 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it was no larger than an average car, it was still a big deal. Out of more than 1 million asteroids astronomers know about, it was only the second one to orbit our planet. Called 2020 CD3, it was our temporary mini-moon. It didn't stay with Earth for long though. The asteroid followed a random orbit and slowly drifted drifted away. Temporarily captured objects, such as 2020 CD3, are rare. They need to have a specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction. Imagine a powerful giant, like the Sun, clashing with a tiny yet mighty opponent, a small black hole. The collision is imminent, and the fate of the solar system hangs in the balance. Will the Sun be able to withstand the intense gravitational pull of a tiny black hole? Or will it be swallowed whole? The answer lies in the forces at play in this mind-blowing cosmic collision, so let's break them down. First of all, what is a black hole? A black hole is a region of space where the gravity is so strong that nothing, not even light, can escape from it. Like a cosmic vacuum cleaner, it sucks up anything that gets too close. It's so massive that it warps the fabric of space-time around it. Black holes are one of the most scary and mysterious objects in the universe, a powerful force of nature that defies our understanding of physics, a true enigma of the universe. Black holes come in different sizes, from small ones that are only a few miles wide to supermassive ones that are billions of times the mass of the Sun. Most of them are formed by the collapse of massive stars. After the black hole is born, it starts to grow in size by eating everything in its path. And if two or more black holes collide with each other, they can merge into one enormous cosmic monster in a terrifying dance. But what about the smaller ones? The smallest known black holes are called stellar black holes. It's a type of a black hole that weighs 3 to the 10 masses of our Sun while being very small. It's like taking all the matter in the solar system and squeezing it into something the size of New York City. And yes, it's considered very small. Just for comparison, intermediate mass black holes weigh between 100 to 1,000 solar masses, and supermassive black holes weigh millions or billions of solar masses while being unimaginably huge in size. So stellar black holes are basically nothing compared to their relatives. Imagine a massive star, bigger than our own Sun and with a heart made of nuclear fuel, burning bright and hot. But as the star runs out of fuel, gravity takes over and starts to squeeze the star. The more it squeezes, the hotter it gets, until the star's core reaches a temperature of billions of degrees. Eventually, the core collapses under its own gravity. This creates a massive blast called a supernova. This collapse creates a singularity, which means a point of infinite density and gravity. This point is surrounded by an event horizon, the invisible line beyond which nothing, including light, can escape. And just like that, voila! A stellar black hole is born. Pretty mind-blowing, isn't it? Stellar black holes are the most common type of black holes we know of. These guys can be found all across our galaxy. So what are the chances that such a little monster will come for our Sun? And in that case, what will happen to us? Well, actually, the likelihood of the Sun colliding with any black hole is incredibly small. It's almost impossible for it to happen. Even though stellar black holes are the most common type of black holes in our universe, they aren't common at all. The chance of the Sun and some black hole crossing paths is so rare, it's basically like winning the intergalactic lottery. Only this win wouldn't be that pleasant. For 2023, the closest known black hole to our solar system is Gaia BH1. It's about 10 times heavier than our Sun, and even this one is about 1,600 light-years away from us, which is quadrillion miles. So it's safe to say that our Sun is not going anywhere anytime soon. But never say never, right? Just like with any astronomical event, we need to understand the different ways something like this could happen. For example, it would be possible if a rogue black hole passed through our solar system, much like a comet or asteroid passing by. Unfortunately, unlike comets and asteroids, black holes are invisible and can only be detected by their gravitational pull. So it's not like we'd see a big, ominous black hole hurtling towards us. Rather, we'd only know it was there if it caused some sort of disturbance in the orbits of nearby objects. So now what? We know that the Sun is a massive, luminous star at the center of our solar system. It's about 4.5 billion years old and has enough fuel to last for another 5 billion years. This star is so big that it's hard to even comprehend its size. In fact, if you were to put all the planets in our solar system inside of it, there would still be room for more. And it's so massive that it contains almost 100% of the total mass of the solar system. So it's hard to imagine how some insignificant, small black hole thousands of times smaller than this star can devour it. And you're right, it won't. Well, at least not completely. So, imagine if a rogue black hole arrived in our solar system and has begun to approach the sun. As it gets closer and closer, the black hole's immense gravity will start to pull material from the surface of the sun. The sun would start to get stretched and distorted. This is called spaghettification. Imagine a rubber band being stretched until it snaps. This gathered material will form a swirling disk around the black hole, called an accretion disk. As more and more material is pulled in, the disk will heat up and start emitting intense radiation. And as the sun gets pulled in, it would start to release massive amounts of energy in the form of light and heat. The sun would become much brighter and hotter than before. The sun's outer layers would be vaporized, creating a massive cloud of gas and dust that would expand outwards. It would be like a cosmic fireworks show, but with terrible consequences. Even though it would be one of the most spectacular views in the universe, we wouldn't be able to see it. As you might have guessed, the Earth would be in for a really rough time. The intense radiation and solar material would cause massive wildfires, and the intense heat would vaporize the oceans. The Earth would be bathed in a constant stream of high-energy particles, and the atmosphere would be ionized. In short, the chances of any life surviving would be close to zero. And this collision would have far-reaching consequences, not only for the Earth, but for the entire solar system. The intense radiation and heat would vaporize everything in its path. All of the planets would be destroyed. Now, the sun, being a much larger object than a typical star, wouldn't be completely devoured by the black hole, but it would be significantly distorted and disrupted. The intense gravity of the black hole would cause the sun's outer layers to be pulled away, creating a massive blast, called a tidal disruption event. But either way, in the end, the black hole would win. It would grow in size, and a new accretion disk would form around it. As we've seen, the collision of the sun with a black hole, whether it be a tiny or stellar one, would be an epic and catastrophic event. But thankfully, as we've already mentioned, the likelihood of such a collision happening is extremely low. However, that doesn't mean we should stop studying black holes and their potential impact on the universe. The more we learn about these mysterious objects, the better equipped we'll be to understand and predict their behavior. So let's keep researching, exploring, and observing the depths of space. And who knows, maybe one day we'll come across a black hole that's just too curious and gets too close to the sun. Let's hope that by that time, we will already be living on other distant planets,